students, myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will study the introduction to liquid fuels, what are liquid fuels and its classification. So here are the topics that will be covered in this session: liquid fuels, then properties of liquid fuels, then classification of liquid fuels, then composition of one of the liquid fuel, petroleum, then biodiesel that is trending today. We will see its composition and its properties. Liquid fuels, these are combustible or energy generating molecules. So they give energy just like the previous solid fuels. But what is the only difference? It is in the form of liquid that can be harnessed to create mechanical energy, usually producing kinetic energy. So these liquid fuels on combustion will give energy that generates energy and used in the form of kinetic energy. So they must take the shape of their container. So we know that solid, liquid and gaseous. Solid, liquid and gaseous gas are three different matters that are present. So what happens? Three different matters. Solid will have rigid, and has closely packed molecules, whereas liquid has loosely packed molecules. So that will take the shape of particular container in which we keep. So it will take the shape of the container. Then it is the fumes of liquid fuels that are flammable. So what is that exactly is flammable? Like if we are using fluid, for example, this is the liquid fuel we have in a container. So the fumes coming out from these are really flammable, not the liquid. So whenever we are burning a liquid fuel, the fumes coming out is the reason for the fire. So that is why the fumes are responsible for the flammable capability of that particular fluid or the fuel. So these are the properties, some of the properties if we see. Density is an important property where ratio of fuel's mass to its volume at 15 degrees is given. So for any fuel, before its application to any industries or practical automobile applications, we have to consider the density. So it is given in kg per cubic meter. So it is useful there for determining fuel quantity and quality. So this determines the quantity as well quality of that fuel or the liquid fuel. Then viscosity, the next one is a viscosity, measure of fuel's internal resistance to flow. So viscosity is nothing but the thickness. So if we see, it is the thickness of that fuel. So it will indicate the resistance or how the fluid is restricted to flow. So this will give an important property during its usage. So most important characteristic for storage and use. So even for the storage also we have to consider this viscosity, because depending on the viscous nature only the storage capability can be varied. So decreases as temperature increases. So what happens to the viscosity? Whenever there is an increase in temperature, the viscosity decreases. So this is the inversely proportional. So wherever increase in temperature, the viscosity decreases. Next is the flash point. So we have seen in the lubricants also, flash point is an important property for fuels, liquids or any other lubricants that we use. So here flash point, lowest temperature at which a fuel can be heated so that the vapor gives off flashes when an open flame is passed over it. That means it is a temperature wherein it will ignite. So that will is nothing but whenever the fuel is heated, the temperature at which it gives off flashes is nothing but flash point. So flash point of furnace oil, for example, is 66 degrees centigrade. So this is the temperature for flash point of furnace oil. If we compare gasoline and diesel, gasoline has lowest flash point. It means it catches the fire easily. It catches the fire easily. So the vapors coming out from gasoline is high comparatively with the diesel. That is why it is catching fire. Then pour point. Pour point, lowest temperature at which fuel will flow. It is the capability of that fuel to flow. That is the temperature in which the fuel starts flowing. So that is nothing but pour point. Indication of temperature at which fuel can be pumped. So if you see in the petrol pumps and all, there is a flow of the fuel into the automobile. So it is the temperature at which the fuel can be pumped. So even during petroleum mining also, there is steam sent into the underground which will push the oil out for pumping the oil into the tankers. So we have to know this pour point before we go for mining or also for the applications. Then is the calorific value. So as we have seen in the solid fuels, calorific value is an important aspect wherein it will decide the heat that is generated or the energy that is generated so that the fuels are classified. So heat or energy produced is depending on calorific value. Then gross calorific value, vapor is fully condensed. It means the vapors coming out from the fuel is completely condensed so that it gives the gross calorific value. It means completely utilized or used. So that is nothing but gross. The complete value of that particular fuel is given by gross calorific value. Net calorific value, water is not completely condensed. For example, if we have fuel plus water or water in the form of moisture, so we have only moisture content. Whenever we have moisture content, there will be some loss in energy. So that will reduce the calorific value. So that reduction or the difference is given by net calorific value. That is the exact energy that is produced from that fuel only is given by net calorific value. So next is the specific gravity. So it is a ratio of weight of oil volume to weight of some water volume at a given temperature. So specific gravity is nothing but ratio of weight of ratio of weight of oil by weight of water. So that will give the specific gravity for that particular fuel. So specific gravity of water is taken as unity. So we know this very well, and it is tested with hydrometer. Hydrometer is used for measuring this specific gravity of any fuel. So these properties will help in practical applications. Then the sulfur content. So the presence of sulfur content also varies. So depending on the source of crude oil. What is the crude oil? Just the oil that is obtained during mining. So during mining is nothing but crude oil. This crude oil is the one which is obtained during mining. So after that, refining takes place and we get different oil products. So that is a crude oil, and less on refining process. So whenever refining process is going on, the sulfur content will reduce. Decreases. So during refining, the sulfur will be reducing. So for example, furnace oil contains 2 to 4% of sulfur, and the sulfuric acid, if at all sulfur is already present and is not properly refined, then the presence of the sulfuric acid causes corrosion. So causing corrosion is the biggest problem we will be facing for automobiles or any industries. So it is very important to take care of this sulfur presence so that it has to be removed during refining process. There is the ash content. So the ash content is also very important, as we have seen in the solid fuels. So the ash content in the solids will be higher. Why? Because it is the solid molecules packed compactly Solid is packed compactly molecules, so it will have high what is that, ash. But what happens in liquid, it is a gauge, liquid has loosely packed molecules that are in containers, so it will have very less ash content. It will have very less ash content. That is why the smoke that is produced during fuel in the automobiles is also less comparatively the smoke produced from the solid fuels. So it is an inorganic material in fuel, and typically 0.03 to 0.07% is only present as ash. Then corrosion of burner tips and damage to materials or equipment at high temperatures. But even if metal is present, for example, in the automobiles, if this ash content is high in the fuel, so then it will be giving smoke. So that will give too much smoke from the silencer. So that is one of the example where it is corroding the parts of that automobile. So it is very important to reduce the ash content. Next is the specific heat. So kilocalories needed to rise temperature of 1 kg oil by 1 degree. So specific heat is nothing but 1 kilocalorie needed, 1 kilocalorie of energy or the heat required to rise temperature of 1 kg oil. 1 kg oil if we take to 1 degree. So that heat required is nothing but specific heat. So this is very important. Kilocalorie per kg per degree centigrade. It means kilocalorie heat required to rise 1 kg of oil to 1 degree centigrade is nothing but specific heat of that particular fuel. And this indicates how much steam or electricity it requires. So how much electricity should be given to heat up that oil to get a desired temperature. So that is very important indication for any fuel before we use it for any applications. So carbon residue, next one is a carbon residue. Tendency of oil to deposit a carbonaceous solid residue on a hot surface. So the oil will have the tendency, a tendency is nothing but it will have the ability to form carbonaceous residue, black residue on a hot surface because of presence of carbon. So the residual oil, for example, will contain 1% of carbon residue. So it is very low, like only 1% will be having. Then water content, normally low in fuel furnace oil supplied. For example, if we take furnace oil, it is generally low. It is generally low, like less than 1% of water content. Water in the form of moisture. So moisture should be very low and it will be low only for liquid fuels. And free or emulsified form, it will be in the form of free or emulsified, can damage surface of furnace and impact flame. So if at all, if it is present, it can damage the surface, corroding the surface, and also impacts the flame that will be produced in the furnace. The storage of liquid fuels, this is very important because we cannot just store with an open lid. So it is very important for us to consider the storage of liquid fuels. Store in cylindrical tanks above or below the ground. Where is the this below the ground happens? Only in the petrol pumps, for example. For example, I am giving you, and here in the refinery stations. So this happens, like the storage must be above or below the ground. So if you see in this picture, these are stored in the cylindrical tanks, and also during transport, if we see in the road transport also, the fuel is transported with a label like hazardous label, with hazardous, with harmful or hazardous label. Always should have hazardous label like flammable liquid. flammable liquid. So if you see this in the refinery or the station, liquefied hydrogen flammable gas. So it is given a very clear indication that during its storage, it should be given flammable liquid, flammable fluid. So the recommended storage is greater than 10 days for normal consumption. So if you see, for example, even in the petrol pumps, the fuel will be present from long ago. It is because of its storage that it is underground. And cleaning at regular intervals is also important for the liquid fuels. Then coming to classification of liquid fuels, there are two types like natural and synthetic liquid fuels. So what are natural liquid fuels? They are already naturally occurring in the earth. Natural fuels occurs in earth or seabeds. Seabed are called natural fuels. So they are again classified into primary and secondary. How are they classified? Primary fuels are like petroleum. They come from this mining of these the fuels from the earth or sea undercrust, like the seabeds. So they are natural fuels, and refining and after some process, whenever the fuels are forming, then they are called secondary fuels. So examples of natural liquid fuels are petroleum. Natural liquid fuels are petroleum. So this is the single largest source of liquid fuel. That is the petroleum. Petroleum means petra is a rock, and oleum is oil. So oil forming from rocks is also known as rock oil or mineral oil and petroleum. So this is the single largest source of liquid fuel we use for automobiles and different applications. So this is very important in daily usage. So it is coming from the word petra is rock and oleum is oil. So forming from the rocks, that is nothing but petroleum. Crude oil as this petroleum is a viscous liquid containing hydrocarbons. Petroleum also contains small amounts of non-hydrocarbons, mineral impurities that we extract from underground deposits at a depth of 500 to 1500 feet at various places. That various places can be either seabeds or the other landscapes, land also. So if we see this in the sea, what happens? Aerobic anaerobic degradation takes place. Then transformation of kerosene into fossil fuels, so they get degraded in the seabeds, and after some millions of years the petroleum is forming in the very deeper under deep of that sea or oceans or landscapes or scapes. So this is, we have to take that oil from beneath the 500 to 1500 feet. So that is the where the oil or the petroleum will be obtained. So as soon as mining, what is the oil that we obtain from mining? Crude oil. Crude oil. That is what we obtain immediately from the earth or seabeds. The composition of petroleum, it is mainly composed of various hydrocarbons like straight chain, paraffins, cycloparaffins or naphthalene, olefins and aromatics. All these together along with organic compounds containing oxygen, nitrogen and sulfur is a composition for petroleum. So just remember that as soon as we get a crude oil, it will contain organic compounds, inorganic compounds and organic compounds containing metals or nickel, vanadium, iron, so on. So these heteroatoms contain sulfur, nitrogen, oxygen, and also hydrocarbons is nothing but hydro and carbon. Hydro is H, hydrogen, carbon is carbon. So just remember that C and H, carbon, hydrogen containing compounds, metals and heteroatoms are present as a composition in petroleum. So if see in this addition, in addition to that, phenol, fatty acids, ketones, metallic elements like vanadium, nickel are also present. So if we just remember this figure, it will give a quick idea and understanding that it has even metals that are coming in the crude oil. So in general, what is the percentages present? Carbon is about 83 to 87%, and hydrogen is 11 to 14%. Nitrogen is 0 to 0.5%, which is very low. Sulfur is also like 6%, and oxygen is 3.5%. Why oxygen is very less? We are taking from Earth only. No, why the oxygen is very less? Because it is under, it is about very deep, like 500 to 1500 feet, where the oxygen content is very low. Then if we see the hydrocarbons, it is the aliphatics that are present, aromatics and naphthenes. Aliphatics with a 25% composition, aromatics of 17%, and 50% are naphthenes. 50% are cycloalkanes are 50%. Non-hydrocarbons are containing with sulfurs, nitrogen, oxygen, and metallics. So sulfurs is very less than 8%, then nitrogen is less than 1%, oxygen less than 3%, and metallics less than 100 ppm. So it is very less in content. So these are the composition of crude oil. Then classification of petroleum based on the presence of this composition. Also, the petroleum is classified in 3 different types. So this paraffinic base type crude petroleum is one of the type, wherein this type of petroleum is mainly composed of saturated hydrocarbons from methane CH4 to C357H72, and a little of naphthenes, aromatics are present. So whenever we are saying paraffinic, it should contain naphthenes and aromatic ring compounds. So they are saturated hydrocarbons. So the hydrocarbons from C18H38 to C357H72 are sometimes called waxes. So paraffinic wax, if you remember paraffinic wax, so any compound containing paraffinic name will contain naphthenes and waxes along with aromatics. The next one is the asphaltic base type crude petroleum. Second one, so this contains mainly cycloparaffins or naphthenes with smaller amounts of paraffins and aromatic hydrocarbons. So this has very small amounts of aromatic hydrocarbons and paraffins. So that is why it is coming under asphaltic base petroleum. So next is the third one, mixed base crude petroleum. It has both asphaltic and paraffinic hydrocarbons and is generally called as semi-solid waxes. So generally called as semi-solid waxes. So this is a classification of only petroleum, that is, which is the largest source that we use as a liquid fuel. Then the other one is the oil shales that are in practice. So these are like solid combustible mixture of hydrocarbons called kerogen. So this is forming from rocks. This is also forming from rocks. So heavy and tar-like oils from oil seal could supplement conventional oil, but they are environmental problems due to high sulfur content. This can also replace conventional oils like petroleum, but has high sulfur. So because of sulfur, it cannot be used because it will be polluting the atmosphere and also hazardous to human. So extraction and processing procedures that includes toxic sludge. So if we see this from this rock, we can obtain this oil shale. But the extraction procedure will contain toxic sludge and uses and contaminates large volumes of water. So whenever there is a leakage and sent to water sources, water sources, it will pollute large volumes of water that we again use it for our daily purpose, so that ultimately again damages liver and kidneys for the human. So that is the main cause why this is not recommended for the conventional usage. And this requires large inputs of natural gas, which reduces net energy yield. So we have to put invest some natural gas in refining, so this again will reduce the net yield that we obtain for the energy. Next is the secondary. So in classification we have primary and secondary fuels under natural fuels. Under natural fuels we have primary and secondary. Primary is petroleum that is occurring naturally, and secondary is processing that requires processing of primary fuel. Processing of primary fuel. So secondary fuels includes gasoline, diesel, heavy oil and kerosene. Gasoline, diesel, heavy oil and kerosene are some of the examples of secondary fuels. These are the examples of secondary fuels. So if we see the secondary fuels, petrol or gasoline is the most widely used liquid fuel, and production of gasoline is achieved by distillation of crude oil. So this is the primary fuel. On distillation we obtain gasoline, which is the secondary fuel. So this is the primary oil, and on distillation will produce gasoline, which is the secondary fuel. So the desired liquid is separated from the crude oil in the refineries. So if we see this refinery, this is the refinery for the refining process. So if we see this, so the desired liquid is separated from crude oil. So the heavy oil, whenever the crude oil is kept in this as such, then the heavy oil go below due to its density, high density. Then the diesel will come up, then the kerosene, naphtha and gasoline. So it is the lightest of all the oils that are present in the crude oil during distillation process. So it contains some undesirable unsaturated straight chain carbohydrates and sulfur compounds. So gasoline contains unsaturated straight chain hydrocarbons and sulfur. So it has a boiling range of 40 to 120 degrees. 40 to 120 degrees. So it is the gasoline that is used for most of the applications. So what are the characteristics of gasoline or petrol? Liquid gasoline itself is not actually burned, but it fumes that ignites, causing the remaining liquid to evaporate and then burn. So during evaporation only the burn fumes comes out, and this fumes will catch fire and flame, or fire will come. It will be flammable in nature. So gasoline is extremely volatile in nature and easily combusts, making any leakage potentially extremely dangerous. That is why a big symbol will be given like a flammable for the containers that is carrying a liquid fuel like gasoline. So it is highly flammable, highly volatile. Whenever it is called volatile, it will be evaporating. So when it is evaporating, it will give fumes. That fumes, if it catches, by chance catches the fire, can give hazardous. It will be fire hazard that will happen. So that is why leakage is extremely dangerous for this particular gasoline. It must be cheap and readily available. For its usage, it must be cheap and readily available. It must burn clean and produce no corrosion, should not contain or less decrease sulfur content, so that it can be used for different applications. It should be knock resistance. This we observe in the automobiles, like it should be knock resistant so that it will not corrode the parts of automobiles, and it should be pre-ignite easily. It should have a high calorific value. This is an important aspect that we have to take care during any liquid fluid in its applications. Then is the other one is the kerosene, the secondary fuel. Kerosene is the next example. Kerosene oil is obtained between 180 to 200 degrees centigrade during fractional distillation fractional distillation of crude petroleum oil. Crude oil. From the crude oil, this kerosene is produced at temperature of 180 to 250 degrees centigrade during fractional distillation. So when kerosene is used in domestic appliances, for example, in traditional ways, we used to use kerosene for cooking purposes. Whenever it is used, it is always vaporized before combustion. So it is the wicks will be vaporized with this kerosene. If, for example, this lamping purpose, if we use kerosene, the wick present in between will be vaporized with the oil that is present in the container, and then only the combustion will takes place. Without vaporizing the wick, it has no capacity for the wick to burn. So that is the best example where we can consider that only the fumes will be making it flammable. So by using a fair excess of air, it burns with a smokeless blue flame. So if it is, the purity indicates from the smoke that is obtained from the fire whenever it is burned. So whenever it is highly pure, it will be smokeless blue flame. It will give smokeless blue flame. So it is widely used as an illuminant in the lamps, then jet engine fuel, tractor fuel, and additives in other industrial applications. Next, diesel fuel and its characteristics. The other example is the diesel fuel in the secondary fuels that are under natural fuels. So conventional diesel is similar to gasoline in that it is a mixture of aliphatic hydrocarbons extracted from petroleum. So it is aliphatic hydrocarbons. Aliphatic hydrocarbons, that is why it will have higher flash point than gasoline. So the diesel fuel is obtained between 250 to 330 degrees centigrade during fractional distillation of crude petroleum. So this diesel is obtained during fractional distillation of crude petroleum at a temperature of 250 to 330 degrees centigrade. Diesel generally contains 85% carbon and 12% hydrogen, and diesel fuels consist of longer hydrocarbons and low ash values, sediments, water, and sulfate contents. So this is there is a slight difference from the gasoline. So it has long hydrocarbon chains with a low ash content. So the ash content that is obtained from diesel is less comparatively from the other oils, and also sediments will be lower, and the moisture content will be lower, and sulfate contents will be lower in that diesel. And the calorific value is about 11,000 kilocalories per kg. So it has very good calorific value, and diesel easily ignites below compression temperature. So diesel ignites at a very low compression temperature and is used as in the diesel engines. It is used in the diesel engines like railways or any automobiles also will use this diesel. So diesel engine, wherever there is a diesel engine, it has a very good application. Next is a heavy oil in the secondary fuel as an example. Example of secondary fuel, it is a fraction obtained between 320 to 400 degrees centigrade during fractional distillation of crude oil, and this oil and refractionation gives lubricating oil. This heavy oil has high density, so it will give lubricating oil which are used as lubricants in the automobiles and various industries. So petroleum jelly Vaseline is a best example for lubricant in medicines and in cosmetics also. So we are using Vaseline in our daily life in the medicines and also in the cosmetics that we apply. So this is one of the example of heavy oil. So greases which are used as lubricants are also coming from heavy oils. These greases are used for automobiles like bikes and cars, and these are coming from heavy oils. Paraffin wax, which is used in candles, boot polishes, wax paper, and for electrical insulation purposes, is also coming from heavy oil. So after some processing, this is converted into wax. Because of its high density, the sedimentation will be high. So that waxes are again converted into candle waxes, boot polishes, wax paper, and other electrical insulation purposes. Next is the other type under liquid fuels. We have two types, natural and synthetic. Natural, we have completed primary and secondary, and the next one is the synthetic liquid fuel. Liquid fuel from coal or natural gas is the synthetic. That is, we are producing liquid fuel from other means, source of means. So this is called as synthetic, man-made synthetic liquid fuel. When petroleum is not easily available, for example, petroleum is not easily available, chemical processes such as a Fischer-Tropsch process can be used to produce liquid fuels, and these are known as non-petroleum fossil fuels. So these are known as non-petroleum fossil fuels. For example, if the diesel looks like this, the synthetic fuel look is this one. We have produced from synthetic diesel, we produce from Fischer-Tropsch process. So in this, what happens generally, the coal or the biomass under gasification with hydrogen and carbon monoxide will produce, which undergoes Fischer-Tropsch conversion and will produce diesel fuel and jet fuel. And also the other one is a natural gas that under steam conditions in methane reformation, again with the syngas cleanup, it will give rise to methanol synthesis. So this methanol is again converted into gasoline. This gasoline is produced from gas that is present as natural gas. So these are the different processes that we do and produce fuels. So hence they are called as synthetic liquid fuels. Next is the biodiesel. In addition to all these, biodiesel is one of the diesel that is in practice today, so that the conventional fossil fuels, the depletion of conventional fossil fuels is helping the biodiesel to come up. So this is an alternate fuel similar to conventional or fossil diesel. So biodiesel can be produced from straight vegetable oil, animal fats or oils. Tallow is like from fish we obtain, or from the beef, and waste cooking oil. So all these are the primary sources for the biodiesel to produce. So from the oil crops, for example, oil from the sunflower will be obtained. The seeds are used for extraction of oil, and then on transesterification process, there is production of biodiesel. So this process, the process used to convert these oils into biodiesel, is called transesterification. So the transesterification process is the reaction of triglyceride, oil or fats, the triglycerides that are present with an alcohol to produce or form esters and glycerol. Transesterification is nothing but from glyceraldehyde with an alcohol we are forming esters and glycerol. Transesterification, esters are forming and glycerol is formed. So this glycerol is a byproduct, and the esters that are present can be used for the biodiesel application. So one of the examples are the methanol is the lightest and simplest alcohol produced from the natural gas component methane and by distillation of wood. So from the natural resources only we are producing this biodiesel, and its application is primarily limited due to its toxicity. This methanol is toxic in nature that affects the lungs, so therefore its application is limited, and used in race cars and model airplanes. This is having high calorific value, therefore it is used in the race cars and model airplanes. Ethanol is used as a fuel most often in combination with gasoline. This is increasing interest in the use of blend of 85% fuel ethanol blended with 15% gasoline. So this is generally used in a mixture of gasoline and ethanol. So this blend is called as E85. In commercially, it is called as E85. Commercially called as E85, that is most widely used. Then butanol is formed by fermentation of biomass by bacterium Clostridium acetobutylicum. So this is the bacteria that is forming during fermentation. It helps the conversion of biomass into biodiesel like butanol. So it has high energy content of about 10% lower than gasoline. So high energy, it can produce high energy. And major disadvantage of butanol fuel are high flash point. It means the ignition will be later, slower, and toxicity and fall order. So the smell will be different and toxic in nature. So that is why it has a limited applications when compared to other fuels like ethanol. So this mixture is widely used in most of the applications. So these are the liquid fuels that are commercially available and also in practice use. So we will see in the next session the refining process. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.